Welcome, stargazers. Might you at any point trust it? Picture a heavenly event so huge that it creates shaded areas on Earth, apparent even without trying to hide. That is the scene we may be near the very edge of seeing. In the Orion constellation, the star Betelgeuse is acting strangely, indicating a looming cosmic explosion that will illuminate our sky more than ever. However, when will Betelgeuse go supernova and what will it look like? According to researchers, what secrets could this heavenly event uncover? Join us as we plunge deep into the details of what's actually going on with Betelgeuse and the effect it could have on Earth and maybe for the whole nearby planetary system. Found around 650 light-years from Earth in the Orion constellation, Betelgeuse isn't just any normal star. It's a red supergiant, quite possibly one of the most glowing stars known to us, shining with a brilliance over 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out for its brilliance but also for its history and importance in human culture. Named after the Arabic expression Yalala, which means the hand of Orion, Betelgeuse has been noticed and documented by ancient civilizations for hundreds of years. It has been a guide for travelers and a mark of wonder for astronomers, with its ruddy shade distinguishing it from other stars in the Orion constellation. Can you imagine a single star overshadowing our whole solar system? To give some perspective on the sheer immensity of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star achieve such huge proportions? At 10 million years old, it's significantly younger than our 5-billion-year-old Sun. However, Betelgeuse's enormous size means it burns through its material much faster, predicting a shorter life expectancy than that of other stars. Now, this celestial behemoth, traversing a volume big enough to contain more than 1 billion of our suns, is approaching its final cycle. When stars of such size reach their twilight years, they don't just disappear. They exit with an extravagant flare, a cosmic explosion blast that is beyond human understanding in terms of its energy and brilliance. Such an event has the potential to dominate a whole galaxy, creating shaded areas of brilliance across vast distances. The last time Earth saw a supernova blast this close was in 1964, sometime before the development of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way galaxy with the naked eye. It remained visible for more than 1.5 years, more brilliant than any other star in the night sky and even visible during the day for several weeks. What secrets do these heavenly remnants uncover to us? Ancient records from various human civilizations, including Chinese and European astronomers, recorded the appearance of this new star. Interestingly, remnants of this blast, in the form of an expanding debris cloud, can still be observed today with complex telescopes, giving us insights into the violent ends of massive stars. Supernovae have been rare for observers on Earth, but imagine, for a second, a stellar explosion so intense that it rivals the brilliance of a full moon, casting shadows on Earth at night and even being visible during daylight. The radiation from such an event could charge our atmosphere, possibly affecting satellite operations and even the climate. Betelgeuse, with its erratic dimming patterns, suggests it may be preparing for just such a grand display. Could we be on the edge of witnessing one of the universe's most dramatic events? Just recently, astronomers made a surprising discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and skywatchers worldwide. Known as the Great Dimming, the star's brilliance, which had been stable for centuries, began to decline significantly. This sudden change was so noticeable that even casual stargazers saw it when comparing Betelgeuse to other stars in the Orion constellation. This means that we're not only hundreds of years away from seeing its supernova blast, but maybe only a few decades or even less. By April 2023, cosmic observations reported that Betelgeuse had returned to its normal brightness levels, leading many to believe that the period of anomaly had ended. In a stunning twist, the following months saw Betelgeuse's brightness intensifying by an astounding half. Such prominent variances, while typical of variable stars, were surprising for a star like Betelgeuse, which had mostly shown predictable luminosity cycles. The sudden and extreme surge in its brilliance pushed the star back into the spotlight, igniting discussions about its future. But what caused this sudden change in brightness? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly throw a divine curveball? Stars are not just shimmering spots in our night sky. They are dynamic entities with life cycles, behaviors, and mysteries of their own. For some celestial bodies, periodic brightness variations can be expected, akin to the rhythm of Earth's seasons. Throughout its stellar lifetime, Betelgeuse has kept a relatively consistent 400-day brightness cycle. However, with the Great Dimming, it appeared to defy its established behavior, testing our understanding of cosmic phenomena. Now, you may be wondering, are we on the verge of a cosmic revelation? While the exact reasons behind Betelgeuse's abnormalities are still under investigation, a compelling hypothesis has emerged. This hypothesis, focusing on stellar activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a massive celestial volcano, quietly ejecting and expelling vast amounts of its material into space. Recent observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a tremendous amount of surface material into the universe. This ejection, a monumental event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a thick dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to scatter or was driven away by the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new events suggest a star that's far from done astonishing us. Many speculate that Betelgeuse may be approaching the twilight of its life, with a supernova event, a sudden burst of energy that can eclipse an entire galaxy in an instant, on the horizon. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star or, in Betelgeuse's case, from the exhaustion of its nuclear fuel, which overflows its mass into the core, setting the stage for a catastrophic collapse. But what drives a massive star like Betelgeuse to its end? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse begin their journey by consuming hydrogen in their cores. This initial phase, known as the main sequence phase, lasts for billions of years and forms the foundation of a star's life. As stars near the end of their hydrogen supply, they expand, adopting new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence stage to the helium burning phase is marked by the star's evolution into a red giant. Over time, as helium reserves decrease, the star undergoes further expansion and shifts into other burning stages, each marked by the fusion of progressively heavier elements. The larger the star, the faster these transitions occur, given the immense gravitational forces at play. Then comes the climax, when iron begins to form in the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced is insufficient to counteract the star's own crushing gravity. The star inflates in size, eventually collapsing and triggering a massive rebound explosion, resulting in the explosive force of a supernova. So, is Betelgeuse nearing the edge of a catastrophic end or simply biding its time? Ongoing research by Japan's Tohoku University suggests that the star may currently be in its carbon-burning stage. Lead scientist Hawk believes the core could collapse within a few years once its carbon reserves are exhausted. But not all researchers agree. Studies from Hungary's Konal Observatory hypothesize that Betelgeuse is still in its earlier helium-burning stage. The one thing all scientists seem to agree on, despite these debates, is that Betelgeuse is set to become the Milky Way's next supernova. But pinning down the timing of this event remains a vast guessing game, with bets ranging from just a few years to 100,000 years. Amid these scientific discussions and speculations about Betelgeuse's future, one fact remains unchallenged: the very nature of our observations. When we look up at the starry field, there's a subtle paradox we often overlook. This paradox lies in the very concept of time and light in our vast universe. Stars and celestial bodies are so distant that their light takes an immense amount of time to reach our eyes. For example, the speed of light, while an impressive 186,282 miles per second, still has its limitations. Consequently, the light from distant stars and galaxies takes time to traverse the vastness of space before it reaches us. Looking at Betelgeuse, you're actually seeing a spectacle from 650 years in the past. To put that in context, when this light left on its journey toward Earth, the Renaissance was just unfolding, and adventurers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through a vast time capsule, giving us glimpses into its distant past. If, for instance, Betelgeuse had gone supernova a century ago, we wouldn't have witnessed its demise until now. Such is the majesty and mystery of the cosmic expanse. As we continue to observe Betelgeuse and its unpredictable behavior, the scientific community remains captivated by the mysteries this star presents. While the concept of supernovae is well understood in general terms, the specifics of what happens in the final moments of a star's life, particularly one as massive and eccentric as Betelgeuse, are far from fully understood. Theoretical models provide us with some clues, but the sheer variety of variables involved in the collapse of a star's core complicates matters. Betelgeuse is, in many ways, an experiment in real time, offering astronomers a unique opportunity to witness the dramatic end of a massive star. One of the most significant challenges in studying Betelgeuse is the unpredictable nature of supernovae themselves. Supernovae are not all the same, and they don't follow a universal pattern, especially when it comes to massive stars like Betelgeuse. Some explode violently and brightly, while others may undergo a more gradual dimming process before finally collapsing into a black hole or a neutron star. The reason for this variation lies in the internal composition of the star, the speed at which it consumes its fuel, and the surrounding conditions, including any interaction with nearby celestial bodies. The most recent observations of Betelgeuse suggest that it may be in a phase of instability as it nears the end of its life. This could mean the star is undergoing an internal transformation, possibly as a result of an internal mixing process or the final consumption of heavier elements. This process could lead to significant fluctuations in its brightness, which have been witnessed in the past few years. While this dimming and brightening might be seen as a precursor to the eventual supernova, it could also be a sign that the star is beginning to shed its outer layers, preparing for its eventual explosion. The behavior of Betelgeuse has given rise to a number of intriguing hypotheses about the specific mechanisms that could be at play. Some researchers believe that the dimming is due to a massive outflow of gas and dust, which temporarily blocks the star's light. This would align with the previously observed material expulsion from the star, hinting at a highly dynamic atmosphere. As the material is ejected from the star, it may create a dense cloud of dust that temporarily reduces the brightness of the star as seen from Earth. This event is consistent with the way some other red supergiants behave in their final years before going supernova. The released gas and dust could even alter the star's light curve, giving astronomers a crucial piece of the puzzle when it comes to predicting how the explosion will occur. Beyond the physical processes at play in Betelgeuse's death, the consequences of its eventual supernova are of particular interest. A supernova of this magnitude will not only impact the immediate region around the star, but it could also have profound implications for the solar system. While the explosion itself is not expected to pose a direct threat to Earth, given that Betelgeuse is over 600 light-years away, the effects could still be felt in terms of radiation. The intense burst of gamma rays, X-rays, and other forms of radiation that accompany a supernova explosion have the potential to disrupt the Earth's magnetosphere, potentially causing disruptions to satellite systems, GPS communications, and even power grids. Additionally, the energetic waves from a nearby supernova could trigger changes in Earth's atmosphere. Supernovae release enormous amounts of energy that can ionize the atoms in the atmosphere, leading to changes in the chemical composition of the air. If the blast is sufficiently close, it could affect the ozone layer, increasing the amount of ultraviolet radiation reaching the surface. While a 600 light-year distance provides a considerable safety margin, it's still important to consider the cascading effects such a cosmic event could have. Moreover, a supernova like Betelgeuse's could also provide key insights into the formation of heavy elements that are crucial to life on Earth. Elements like gold, platinum, and uranium are created in the violent explosions of massive stars. And these materials are spread throughout the universe when a star explodes. The remnants of supernovae can enrich the surrounding interstellar medium with these precious metals, which may later contribute to the formation of new stars, planets, and even life. In this way, the death of Betelgeuse could directly influence the future of the universe, seeding new generations of stars and planets with the building blocks necessary for life as we know it. Another exciting area of research is the search for any precursor signals that might help scientists predict when Betelgeuse will go supernova. Although predicting the exact time of a star's death is incredibly difficult, astronomers are looking for any signs that could help pinpoint when the final explosion will occur. These signs could include unusual changes in the star's brightness, changes in its spectral signature, or the emission of unusual particles from the star's outer layers. By closely monitoring Betelgeuse in real time, scientists hope to build a more comprehensive understanding of the processes leading up to a supernova and to potentially catch a glimpse of the last stages of a massive star's life. In the coming decades, we may witness the grand spectacle of Betelgeuse's demise, a show that will captivate astronomers, skywatchers, and perhaps even the general public. The explosion of this star is expected to release an unprecedented amount of light, visible across vast distances in the galaxy. The light from a supernova can be so bright that it outshines an entire galaxy for a short period of time, making it one of the most energetic events in the universe. While Betelgeuse's eventual supernova won't be a catastrophe for Earth, it will still be a moment of awe and wonder for humanity, a reminder of the incredible forces at work in the cosmos. As we look up at the night sky, we can't help but wonder when this majestic event will occur. The fact that we may live to witness the end of one of the most famous stars in the sky is an extraordinary thought. Betelgeuse, with its unpredictable behavior and its eventual fate as a supernova, offers us a unique glimpse into the life cycle of stars and the dynamic nature of the universe. As we continue to watch, we are reminded of the vastness of space and the infinite possibilities it holds.